class. We were just finishing up this little part of log cosines, which is way fun, right? We're just finding the angle if we know side, side, side. So we're right here. And I'd like to just give you the formula if it's an angle, but it would just be cosine inverse. I need pen. So it would just be cosine. See, it's just going to move on me. Just dumb. Oh well. Maybe I can write it right here. Cosine inverse of whatever the side opposite it is. So opposite side squared minus leg squared minus leg squared all over -2 times leg. And you just plug that in your calculator and you've got the actual cosine angle there. Okay. So, but I'm going to go ahead and just solve this next one, how we did it before. This is the angle. This is the side opposite. On law of cosines, you need to figure out that first so you know what is going to be equal to what. So 16 squared equals, so you know that that's the side by itself. And then 5 squared plus 13 squared minus 2 times 5 times 13 times the cosine of x degrees. Okay? And then we subtract the two numbers that are being added to both sides. So 16 squared minus 5 squared minus 13 squared is equal to -2 times 5 times 13 times the cosine x degrees. Then we divide by -2 times 5 times 13. Now you can do this whatever order you want. If you want to multiply all the bottom out, that's fine. But I just write cosine inverse because that's going to be your angle is equal to, remember we have to use inverses here when we're looking for angles. Cosine inverse is 16 squared minus 5 squared minus 13 squared all over -2 times 5 times 13. All right, so that's where we're at. And then you can just plug that into your calculator. I even will extract, I'll grab and change -2 times 5 times 13 on the bottom. And on the top you have 16 squared minus 5 squared minus 13 squared. 16 squared minus 5 squared minus 13 squared over -2 times 5 times 13 means that it's approximately 118.5 degrees, right, for that angle. So those are when you have side, 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 you have to actually solve. Luckily, if you have side, angle, side, if you have what I call a wrapper, I like to think of it as a wrapper because you wrap side, angle, side, wrap the angle in the two sides that you know. You can just set it up and plug in your calculator and have at it. But these, when you have side, 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 then you have to do a bit of solving. All right, so next one, example 6, you have a triangle LMN, okay, where LM is 25, MN is 20, and LN is 24, and you're asked to find that angle right there, angle L. Okay, so for angle L, this is the side opposite is 20, and that's the one that you square and leave on one side alone. 20 squared is equal to 24 squared plus 25 squared minus 2 times 24 times 25 times the cosine of x degrees. Right? So hopefully by now you've got the formula memorized. We do cosine inverse of 20 squared minus 24 squared minus 25 squared all over -2 times 24 times 25. Okay. And that's just solving. So we'll start in a calculator. I'll just pull this up so you can see again. I don't know, I think that's probably helpful for you guys to see what to do. So you're going to do second cosine. So you're looking for an angle. We learned that a few chapters back. And then n over d, so you have a fraction, 20 squared minus 24 squared minus 25 squared all over negative 2 times 24 times 25. Go arrow out and put your parenthesis. That's what you're finding the cosine inverse of that ratio. And that is 48.1 degrees. 48.1 degrees approximately. Alrighty. Okay, so we have a couple of little examples here where we have to draw up our own triangles. So Jack and Tom start at a tree. Okay, and begin running apart at an angle of 23 degrees between them. If Jack runs 50 meters, so here's Jack, and he ran 50 meters, and here's Tom, and he ran 38 meters. Find the distance between them. So that's your distance between them. All right, so this is a wrapper, so that's pretty cool. Those are better, easier to deal with. You don't have to write it out and then solve for x before you plug it in the calculator. You just get to plug it in the calculator. So that distance is going to equal the square root of 23. So glad we're not looking for an angle. Sorry. 38. Got all happy. Okay, so 38 squared plus 50 squared minus 2 times 38 times 50 times the cosine of 23 degrees. Oops. All right, so in the calculator, oh, that's totally going to cover it up. Let's move it so it doesn't. Okay, so I'm going to clear everything out. Square root 38 squared plus 50 squared minus 2 times 38 times 50 times the cosine of 23 degrees. All right, so they are 21 feet apart. So 21 or meters, 0.1 meters apart. All right, which is pretty cool that you can figure that out. All right, two radar stations, 2.5 miles apart, are tracking an airplane between them. So here is the airplane. I'm hoping here's tracking tower. Here's the tracking tower. All right, and they were what? How far apart? 2.5 miles apart. And they're tracking an airplane between them. So here's the tracking the airplane between them. The straight line distance between station A and plane is 7 miles. This is station A. The straight line distance between station B and the plane is 9 miles. Okay, what is the angle of elevation from station B to the plane? So they want this angle right here. Right? So if that's the angle, this is the side opposite. That's going to be your 7 squared is equal to 2.5 squared plus 9 squared minus 2 times 2.5 times 9 times the cosine of theta, whatever that is, degrees. Okay, so we're going to do cosine inverse of 7 squared minus 2.5 squared minus 9 squared all over negative 2 times 2.5 times 9. Okay, cosine inverse, second cosine. I don't know if you want to see this, but I'll just put it here so you can, just in case. Just have to plug this in. Second cosine, and then do your n over d, 7 squared minus 2.5 squared minus 9 squared. Let's do that from memory. All over negative 2 times 2.5 times 9. Arrow out. It's 2.5. And that's going to be 31.8 degrees. So that's the angle of elevation from that station A, or station B, 31.8 degrees. Alrighty? Okay, good luck with your homework. If you have any questions, text or email me, let me know. And I'll see you later. Good luck.